So Ikari quite recently. So this project is called the paper is called Building GNN. So the idea is if you understand how large language models predict the next word from a previous word, similarly, here is that we adapt that concept where given a partial 3D building with the semantics, with the programmatic semantics, could you then also predict the remaining parts? If you like, is like an it's like an outpainting or inpainting in 3D, but using graph neural networks, and also a flavor of recurrent neural networks, where we could learn long dependency, just like you want to guess the next word in the previous paragraph, that is like a long dependence. But if you want to predict the next word based on the preceding word, that is short-term memory. So in this case, it is the same idea. And then the other paper that was also published looked at in a similar sense, trying to bridge BIM and AI, but using the work in with variational graph encoders, where given the footprint, the boundary condition, we in fact predict the composition at a much finer, higher granularity. Papers have been also published in other non-architectural contexts like the ICCV and AAAI. So the first one is really a collaboration with Zhejiang University. Is looking at the layout with image synthesis, but this is quite old, 2021. AAA, I presented with a kind of generative metaverse. So yeah, if you can actually search online and download the proceedings. Also in these top tier conferences, they have like art gallery, art exhibition where they accept artists who work in that space. So the more recent one is CVPR Art Gallery, which is the Conference on Computer Vision and Pattern Recognition, where the neural artifacts projects, two of them been included. And also in the more traditional context, Singapore Design Week, for instance, looking at how to combine eye tracking, brainwave signature with generative adversarial network, and also diffusion models, how these could become a way to map the implicit trigger in the brain in vision with the generation of interiors. Also quite recently, last week, this old project won the WAFX for digital world and digital technology. Yeah, so these are some of the contexts. And I'm also part of a group that unfortunately hasn't been too active. I've been busy since it was started in 2020. So late 2020, in fact. So quite early. Some of the members names might be familiar. But I think the last activities that we organized was in Michigan, 2022, late 2022. Yeah, last year was been a bit quiet. So I'm also quite involved in the local AI creative scene, design and art scene. Obviously now it has entered mainstream. Suddenly there've been great interest from business, radio, to lifestyle. So we see that this topic is across the board, right? Also in Singapore, if you're curious about the current situation in Singapore, there is quite an emerging local AI architecture scene. So quite recently, there was this Young Architects AI Hackathon, of which I'm the jury. In the jury, and we see young architects beginning to join these activities and trying to learn a bit more on how AI may be applied in architecture practice. So I'll talk about the main focus today. Now they have a sense of the context of with which I worked in. I want to talk about neural artifacts. So artifact can be defined in several ways. If you just look at the dictionary, right? It's an object shaped by human hand, or it can be an object found in archaeological excavation, or it is something that is not a true feature in an experiment, meaning an experimental error, or it can be an object made or shaped by some agent. Interestingly, not necessarily of direct human origin, meaning it could be of non-human origin. And in an algorithmic context is a perceptible distortion, like a glitch. So it's quite interesting looking at the array of definition of the artifact, because they are almost contradictory by definition. So is it by a human or non-human? Is it a true or false feature? Is it an error or not? Is it made or is it found? Is it old in an archaeological sense or new in a digital sense? So to recap more visually, you could split the definition of the artifact. So I talked about artifact before I talk about the neural artifact. The artifact can be therefore understood in the art and design sense, in the science and statistics sense, in the computing and AI sense. So in the case of art and design, it is something of historical interest, which is actually quite interesting because after all, much of the data points, the training data sets, they are of historical interest, construction, or at least it produced by human. Yes, these days we have syntactic data set, but there is this idea of the archival. And also in science statistics, as I mentioned about, I think there's some, sorry, there's some noise coming out. In science and statistics is, as I mentioned, is an error which is not desirable. But in this is when it's a bit more interesting, where the glitch is a means to see what's behind the digital. Where we begin to see the decomposition of its constituent parts. Just like when an image is split into this RGB glitch scenario, you begin to see that it is in fact a combination of 3 to 4 channels. And also, but in terms of neural artifact is interesting also in the sense that it plays out in the aesthetic and the epistemic arena. So for instance, just listing some examples, starting from the one on the right. I think last year there's been work being done to poison diffusion models, poison these black box diffusion models in order to grant the artist whose data has been used without permission to destroy these, in this case, diffusion models. So there is this reactionary, subversive part to this, the creation of deliberately confusing artifacts. In the middle, this is quite old. It is a kind of geometric aesthetics that emerged from the desire to confuse computer vision algorithms to not recognize one's face. But through that subversive act, new aesthetics begin to emerge. The one on the left is something that is quite commonly found in any 2D to 3D, text to 3D work, where it's called the Janus effect. I will show some projects that illustrate this, if you like, hypercubist aesthetics, which question the ways in which we place importance to certain views of objects, certain ways of, if you like, perceiving or seeing design even. So you may see some projects that look weird, but weird in the positive sense. So quoting Mark Fisher in his, this is, I think, his last book before he passed away, The Weird and the Eerie. So the weird thing is not wrong. After all, it is our conceptions that must be inadequate. So examples of the weird could be black holes, dark matters, dark energy, and AI, in the sense that we kind of know them, but we kind of not having the ability to fully understand them or even fully visualize them and perceive them. And this also is kind of in line with many of the earlier interests in AI arts, in the uncanny, in the in the Freudian kind of way of re-looking at things. So dual artifact, we could look at it from an epistemic sense. So epistemic artifacts, in fact, buildings are epistemic artifacts because themselves contains, embed much of the knowledge. So here, just quoting from this book from 2023, Epistemic Artifacts. So architecture artifacts are negotiated as epistemic objects and autonomous and innovative form of knowledge capable of inaugurating and institutionalizing architectural research. So essentially, the multi-dimensionality of buildings or actually embed knowledge, which is what we do in architecture, right? We look at previous past projects, important buildings, and we learn from them. And AI artifacts is a bit different. In the AI world, is defined as I wrote here, the output generated by the training process. These can be a fully trained model, basically anything that's been used. So for our purposes, I'm interested in the possibility of an architecture aesthetic and epistemic, which are native to the very nature of the AI system. In our case, specifically Gen AI. So using the more familiar analogy of digital natives versus digital immigrants, right? So digital natives are those, it's in a demographic kind of generation differentiation between those who were born post 1980, and where the ways of seeing is very different, the ways of thinking is a bit different. So here, what I'm seeking to question is that might there be a new and more potent formal conception of AI architecture in the sense of a Gen AI native? What is a Gen AI architecture beyond the sort of cliche things that we see that has already flooded the internet, some cliche mid-journey stuff whatsoever, but is there in fact a native language embedded? So for instance, the Janus double-headed panda that you saw just now is actually some of the nature of this system that produces these former expression. So then here is the difference between the artificial architecture as the Gen AI native versus the architecture artificial, which is the Gen AI immigrants. The focus is this, is the recursive artificializing of the architecture. The reason I use the word architecture is to not kind of constrain it to just buildings, but anything that is architecture, even in a conceptual sense. So artificializing architecture signals the possibility of a fundamental shift in the conception. So the key part is the conception of architecture, and hopefully a renewal of its aesthetics and epistemic, meaning the ways in which we experience architecture, perceive architecture, and the ways in which we learn, understand, and therefore produce architecture. And in doing so, it will begin to have a new definition. So it is more fundamental, whereas the architecturalizing AI is a lot different. Architecturalizing AI, here I wrote, alludes the possibility for a fundamental shift only in the operation of architecture. Therefore, only in the renewal of its workflows and finding its production while still reinforcing past aesthetics and epistemic. Essentially, we're forcing we are kind of limiting the potential of the act of artificializing and force it into the old ways of working in architectural thinking. So therefore, there are projects that would be in this form where it sort of improve the workflows, it sort of change the operation, it quicken the process, it produce more options, but essentially it does not radically augment the prior aesthetics and epistemic. So this is the difference. So to sum up, the artificializing of architecture is therefore interested also in the tracing of the AI artifacts. So how might AI broaden the conception of architecture that we do not yet know? So it's like the weird concept, the black holes and all that. We're trying to understand, describe it. So it's closer to the more than human, to the more than architect. Whereas the other one, which is the architecturalizing of the artificial, is closer to the using AI tools. So how it could aid, let's say, how could AI support the production of architecture that we know now already? So it's really quite all too human and all too architect. So to also make it, so for those who are quite familiar with design thinking, I think architecture students are probably less familiar, but design engineering students are very familiar. There's this standard design, double diamond, they call it, where the design process could be summarized as with two diamonds. So first you have the problem, which is a problem space, and then you arrive at an intention. So you could imagine the first diamond is where the brief arrives, and then you kind of explore, what would the design be heading in whichever direction. And then once the intentionality is confirmed, you begin to develop your concept, schematic, design, and arriving at a solution. So there is this problem space and solution space. But if we refer back if we look at the x-axis and y-axis, where the y-axis is the space of possibility, the space of problem, the space of solution, whereas the x-axis is the time of production, the time of delivery, then really the y-axis is in fact the artificializing of the architecture, which is concerned with the conception of architecture, whereas the one at the bottom is the production of architecture. Of course, they are not necessarily mutually exclusive. You may gain one via the other, but hopefully this might help. So again, this is quite an old diagram that was done, the vision that was done, to kind of question even the very process. So unlike, if we stick to the double diamond idea, it's really to just, quickening the process. But AI actually will bring in very different forms of design ideating and design solutioning. So you could, for examples, would be the fully automated, the fully autonomous, the semi-automated, the semi-autonomous. There is a huge difference between the automated and the autonomous. The automated is like, is rule-based, right? It's deterministic. It's without not true, but probabilistic agencies. Whereas the autonomous it makes decision on its own. Therefore, if you look at this diagram on the top right corner, is that the humans can actually be removed from the point of intentionality. What it gains is the speed and space, but what it loses is the human agency. and it seems to me that the semi-autonomous might be a good way. So this is really about how we also work with these new AI systems, where we position ourselves within that process. Yeah, I think we should move on. This is, I can jump, but this is very old. It's trying to understand the affordances of these models, creativity and sensibility. But it seems to me a good sweet spot might be top right, where it's a kind of a good balance. And this, I think I was dumb. So can we think about AI architecture discourse as this continuous artificializing of the architecture? So AI artificiality, we can, again, as I mentioned, here we can actually split it into the shallow artificiality and deep artificiality. So shallow artificiality is essentially AI conceptualized as an aesthetic machine for the simulation of outputs of any style. So this is what we have now, currently. Whether is it Stable Diffusion, Midjourney, whatsoever. This is, or DALL-E. This is what we have, is a simulation of outputs of any style. Whereas the Gen AI native, the deep artificiality, is AI conceptualized as an aesthetic machine with its own style of simulation process. So, for instance, there are many, right? The Genius effect is one, for example. So it's not so much about the style of the output, but rather the style of the process that generates the output. Because essentially these deep generative models are simulation machines. But to move to a deeper level is to actually understand their style of simulating. So a bit more concrete examples of this conceptual, some examples of this concept of the neural artifact. One, for instance, could be the conceptual slippage, one word to 3D forms. So, for instance, this is old. I mean, this has been around from René Magritte, Les mots et les images, and it's really the idea that the word is deliberately not the thing. So there is this conceptual ambiguity that's quite inherent, or more interesting. This kind of shifting relationship between words and concept. The other one, which is more operationally useful, is the formal slippage. So we know in let's say nerves, neuroevidence field, or 3D Gaussian splatting, this sort of 3D reconstruction of 3D scene via 2D images. Actually, algorithms, models that live in the 2D world but made to construct 3D worlds. And this is where the hypercubist thing comes back, where there is a prioritizing of certain formal presentation of objects, but also at the same time is ambiguity. Okay, I think the time is a bit short. So if I read some of my earlier writings from 2020 to 2022, I spoke quite a bit on the concept of architecture sampling, architecture plasticity, architecture noise, and it was really to describe the components of these machines, AI machines, and also looking at, I tried to do it quite briefly for this one. So, for instance, architecture noise is actually an essential element. Even just looking at currently, right? Not just diffusion models in the past. the noise is always an element that's necessary. And in the case of diffusion models, even more obvious. The whole idea of noising and denoising is actually a crucial aspect of these models. Plasticity is in every sense. First, the idea from neuroscience, where the brain is essentially plastic, so neuroplasticity. But also, it is so basically the change of weights. I mean, if you've developed AI models before, yeah, there is this deliberately disconnecting certain weights in order for the model to be able to generalize better. So these are kind of inherent. So it has this. If you're interested in the more philosophical aspect of it, you can read Catherine Malabou, where she brings in plasticity into the aesthetic, into the ethical, and also the political. But more relevantly for our purposes, is the ways in which she interprets this. So in three ways, of which the last one is particularly interesting, because it relates which is the plastique, which is an explosive concept. So in that sense, it is plasticity is in two extreme, is form making, taking form, like sculptures and object making, but also the annihilation of all forms, which is about explosion. And this is where the some of the uncanny output from these models seems surprisingly interesting and surprising. This, if you're interested, you can read a bit more, where I wrote about sampling is almost an essential aspect of design, or generally in life, right? But in the case of AI models, there's this whole process of curating the data, and of course the model then sample them, and also the sampling from noise distribution, but also sampling from the latent space to generate the output. So sampling is actually a very core formal basis. And in the architecture sense, if you're interested, you can check my PhD a few years ago. And I went quite deep into sampling from a pedagogical understanding, a technological understanding, and an aesthetical understanding. So, for instance, the word sampler is actually a physical pattern reference in embroidery, or in fact, it's a curriculum in Victorian era. In the technological sense, sampling is understood as this analog to digital converters, or in synthesizer where you create sequencer. In the aesthetic, which is actually closer to the deep learning part of it, where we had much earlier on non-parametric sampling and parametric sampling. Now it's parametric sampling. In the past, because all deep neural networks are essentially parametric models. Whereas in the past, like in kind of texture synthesis of the 90s, late 90s, these are non-parametric, which are dependent on kind of a discrete description of the sample. Yes. So in the text, I also looked at the architectural grid, that's meaning the structure of sampling. So first is the semantics of sampling. What does it actually mean? The structure of sampling. What is the structure? We're very familiar with grids. We're very familiar with sequences, but there is and now the hierarchical sampling, right? There are sampling in different within hierarchies. But yeah, this I want to talk more, and eventually arriving at this notion of, in fact, there is this there isn't any notion of the figure and ground, which has been sort of taken for granted in architecture discourse. We always think there's a figure and there's a ground, but in computations, in these AI systems, there's no original notion of figure and ground. Yes, there may be a depth map, yes, there may be semantic segmentation or given an image, segment and locate the object, but these been sort of embedded by the human designers, the human computer scientists. But there's no real reason that there need to be a figure in the ground, and also going against the notion of parts and whole. There's really no parts and whole because it is really dependent on actually the resolution of perception. So I also talk about no shapes, no grammars. So this is kind of moving away from rule-based system that was really trendy back even in the, I mean, the early fathers of intelligent architecture. You can trace back, including the shape grammars people that started in MIT. But really, there's no real need for notions of grammar or shapes because the machine sees the texture sometimes more than the form. And so then really the reality of there's no figure, no ground because everything's flattened. There's no parts, no whole because it's purely resolutional. There's no shapes and no grammars because everything is probabilistic. And yeah, I'm basically squeezing a lot in this presentation, but if you're keen, you can check out. There is this much later publication in Architecture Intelligence Journal, where I have a compressed version of this without having to read through the few hundred pages of the thesis. So now we enter the projects in case it's a bit too heavy on the theory side. One project, this project actually expresses the Janus effect. So this is the bench that was commissioned by the National Arts Council. I mean, if you're in Singapore, you can actually sit on it. It's still there. It's sort of a permanent installation. And so if I run this quick video, which itself is actually a new Iridian sphere. It's not a video I didn't have a drone to fly around, but I train a model. You can move in that space however you like. So the bench is being treated as a building in the sense that it takes on its site condition. So it's back-facing the Asian Civilization Museum, which contains Malay and Chinese furniture artifacts. And it's facing the Singapore River, which used to have like boats on it in the old days. So it's trying to, if you like, blend the idea of boats, which like we call it sampan, and furniture pieces, antique furniture pieces. In this project, it's much deliberate to show this disjuncture of the burnt part of the bench and the unburnt parts. The burnt part is black in color. So if you so the model's been, you saw the generative process. The model's been generated so this is the process of actually extracting the antique furniture features. So it basically is this idea, right? Combining the both with the benches, but and also the whole training process actually, where we create this concept. And the material level is actually also, so conceptually, it, if you like, upcycle the concept, it upcycle the formal features of furnitures and boats, but at the material level is actually made of abandoned boats and abandoned furniture pieces and architectural pieces, doors and windows frames. So it has this sort of combined, in parallel, conceptual, material parallel. So at certain angle, the bench actually looks like, on full elevation, it looks like the front. If you look at the back in orthogonal full elevation, it looks like a front also. And this is where the side begin to hallucinate. And in the end, what we saw is that it splits up. We can also identify this confusion at the bottom part of the bench, where it, on elevation, it seems like the two front legs are connected, but actually they are not. And the model has to figure out how best to, I mean, we do some structure optimization also, but that's the idea. This other project, I'm showing it also because in 2022, Cadra was held in SET, and I was in fact there in person. But this year it was in just this April. I was in SUTD. I was the chair. But here, unlike all the previous and at least different from next year as well, the interface has been designed that it accentuate and try to articulate the process of crowdsourcing and data sourcing and sentiment analysis, in the sense that if you've ever gone onto the web, you're asked to choose whatever colors you like, whatever gradient, and then we just collect that. So for 9 months, we collect the full data log. And then at the end, we use that to generate the visual identity of the conference. And through that process, you have to prove that you're a human, like a reCAPTCHA kind of thing. And yeah, and also present very transparently the data points that have been generated by every single person who has visited the website. So it's a very different take on what's a conference ought to present itself. Some pictures, if you've ever been to SUTD. Yeah, and from there, we also had, at the same time, we had an exhibition, which is almost an extension of the bench project. However, this is more for interior, and we did like 8 of them, and it's exhibited at the National Design Center. This is a snapshot of the exhibition, a quick video. So if you're not familiar with monoblock is the kind of plastic. So this is like a critical project in the sense it is a critique project, where it critique on the monoblock plastic chairs, which is this disposable white, in fact, all white plastic chair that's produced with the injection mold process. They're called, in a single piece, they're called monoblock. So here, contrary to the monoblock, it is not thin, it's not surface-based, it's volumetric. It is made of wood. It is not white, it's black. It's not structurally optimized. It has a difficult silhouette because it has a hypercubist, because it's generated from 2D images, right? The 3D is an inference from the 2D, the hallucinated 2D representation. And in the exhibition, we also presented how others previously has tried to use the monoblock as a critique of modern design, but these are often in a collage sense. So again, the project is to clarify that the Gen AI process is very different. Is a kind of high dimensional collaging. In fact, we shouldn't even use the word collaging. It's a high dimensional synthesis and sampling process. So here are early studies where we generate the 3D chairs, and these are a bit higher res, but you see it suffers from interesting ambiguity also in the former structure. Here, just a quick, it's actually generated from multiple views. But here, for the sake of clarity, showing the 4 silhouettes that then generate the eventual object, the chair. So there are 8 of them. So this is how. So the idea here is this: with the hypercubist aesthetic and formal expression, it also produces a hypo use functional. So, for instance, in the first image, we see that a standard monoblock chair has only kind of one function. You sit where you're supposed to sit, and you have where you're supposed to look, and it doesn't do much beyond that. But in a kind of crazy Gen AI synthesis, it creates this ambiguous functional sitting that produces greater affordances of interaction between the pieces, interaction of people walking around, because it's sort of not a single facing object, it's a multi-facing object, and of different size and different use, which was not expected. Of course, there is a process of curating the final output, but So these are the ones that I figured quite interesting because they could be used for all sorts of human occupation, right? You can lie on it, you can put your cat in there, I don't know. This very old project that actually recently won the WAFX, which I mentioned, is this 2021, so it's very old. But it was the era before the pre-trained model era, which we are now in. So this was trained from scratch from 3D models of public housing, we call it HDB in Singapore, and it contains not just the voxel, but actually the voxels with the semantics, meaning the programs. Is it a corridor? Is it a lift call? Is it a stair call? Is it the the apartments units themselves? And the fact that it's based on the 3D learning process, it learns the 3D form, the programmatic 3D distribution. Unlike the auto-completion GNN, the one that I spoke about earlier on during the presentation, this is you generate one whole building at one go, right? And so here is just showing some early data exploration analysis, EDA. The whole, so there's a need to actually figure out, because you're training from scratch, you need to know that your data set should be reasonably diverse so that you don't produce you produce interesting output from a diversity of training inputs. These are real buildings. You can, if you copy paste the geolocation numbers at the bottom, you would actually find a real building in Singapore. So this is the training set. The texture colors were ignored. We're just looking at the massing, and here we're seeing the evolution of the training process. Of course, there are instances where are particularly interesting, unexpected, and premature, and in the formal sense of architecture. It was subsequently exhibited in Singapore in an art context. Yeah, these are just some pictures. So as I mentioned, you don't model anything. You train and you generate the whole building. And as you walk, sample through that latent space. And 3D, since that generate 3D, you can 3D print them directly. I should move a bit quicker. Some examples. This project, we're ending in October. So this project, I will zoom into. So this project is about rethinking about circulation. So again, as I mentioned, I work across different contexts. This is kind of a urban scale about mobility, and it's with a funding agency. The one that you saw just now is a bit different. It's more like an art design context. Here, these graphs are in fact the way early neural networks architecture that we developed and evaluated. So the idea is this: instead of running simulation, we train a graph neural networks that could predict the crowdedness and therefore generate recommendation for planning. So essentially, you architects will produce the planning for development control planning submission, and then the authority wants to inform the submitting architect that there may be some issues of compliances of mobility. So the model does that within a few seconds, under a few minutes. But if you do it traditionally with a simulation software, agent-based system, it will take hours and hours, and it's just a simulation. So this is a quick video showing the process, right? So you've got the floor plans, and then we have to, if you like, feature engineer in the sense that we have to decide what goes into the attributes of the nodes and edges. Here, the point is to predict the edges based on the nodes, of which the nodes are each represented by their area, their usage. This is a shopping mall, in case you are wondering. So you've got shops and corridors. And so we have to kind of decide on the number of features for the inputs for the graph neural network. So we decided, okay, we can use the short pipes and the area as a basis. As shown here, the abstraction is defined by the area and the usage. And with that, we can begin to create, here showing the movement, right? This should be quite familiar for those who've done parametric design, the shortest part. But from there, we begin to compute and generate synthetic data sets of hundreds of them. Because if you, so this is, and then so here, once we permute the attributes, we can begin to train a model, right? Whereby each data point could be 200 variation of it because we permute the attributes. And then this is a probabilistic approach where we then allow the model to be trained. So instead of training with like really 1,000, 10,000 shopping malls, which you can't get hold of, you train with maybe 20, of which each of them is permute into 200 malls, different malls with different attributes. So from here, what you can do is that this whole process of this complex process of, after simplifying the graph, can we recommend? So we can actually recommend, because if we see there's a kind of a congestion shown on prediction, we could have recommendations saying, okay, maybe the width should be broadened, even though it complies with the regulation. Or we can change the program distribution. Maybe instead of having a restaurant it should be a retail, so that we could adjust the probability and then again readjust the entire mobility distribution. And so this example, I show it in a bit more detail also because it's, at least you have an impression that there is this use. So that project is closer to the architecturalizing the artificial, whereas the previous project is closer to the artificializing of the architecture. This project that we worked on been quite slow, but we've been working with the code team since last year, but progress has been a bit slow because of sometimes because of the time zone difference, right? I think is to understand different representation. So we know about multimodality. So a building can be understood as text, can be understood as images, can be understood as 3D models, could be understood as experience. So that's one thing. There's a multi-model representation of a building. But also we could up that thing by producing greater multi-versions of the same modality, meaning a text can be synthesized to create more text that begin to interrogate the original text. So there's this whole complication of given an image, give me a text, given text, give me more text, given an image, give me an image, given a text, and generate a graph and with GPTs. And then from there, we combine this even greater multi-model representation of the original artifact and begin to kind of further analyze, such as doing clustering, topic modeling, and kind of generating taxonomy, which we actually did. So we look at 169 projects from the practice, and we begin to figure out a way to score them so that you can, if you like, compare apple to apple rather than apple to orange. So if we decide that so we're going beyond. Usually, you compare projects. Is that okay? This is a commercial project. This is a educational project. This is in this country and that country. And so these are, they're useful, but they're not fundamentally useful from a kind of design language sense. So we're trying to go deeper by a generative taxonomy, right? And from there, we can begin to compare projects with projects. But on a more formal level, we also worked on the 3D part of it. This is quite old. So looking at, it's quite old. So we trying to generate the old projects in full 3D. So So this is not model. I mean, the right side shows some of the initial experiments that doesn't not exactly successful, but we can already see that these models are capable of generating the entire hardscape, not just the building, but the hardscape. Of course, we did some image stuff as well in parallel with the 3D stuff, and also we're trying to look at the kind of how we also could rethink about the design in its interpolated sense as architectural models. So this I won't show much because yeah. So but the project with MVRDV is to understand. So with their next team, so next is their basically the ZHA code version in MVRDV where the competition. We in the process of actually re-encoding, actually resampling, a good way to sample their 3D models, and from there we can understand their typological language, which we are probably familiar if you are a fan of MVRDV. They have a way of talking about their projects, and what if these could be part of the workflow in combination with performance metrics. What does it mean to have this parallel conceptual generation with environmental performance? So this is, but to start with, we need to actually clean up the data set, which is in progress. This other project looks at this, which is another strand of work that we do in the lab. And this is not coincident at all. We are interested in the natural neural network, but biological neural networks and also the artificial neural networks. But it's also important for us to actually understand how people perceive space, and then in combination with artificial neural networks to then generate them. This is partly to avoid. There's this whole saying in recent times about the web is just flooded with synthetic materials and just trash, garbage, right? So that it's one thing to artificialize the architecture, but it's quite another thing to be not critical about the curation of the output of this process. So there is this inherent intention. This is a quick video. We work with product furniture company as well, and this is one that we presented last year in the Singapore Design Week. It's quite simple in process, but essentially essentially trying to generate an interior with furniture. So you enter this their website and you choose whatever you like, and then even if it seems consciously not matching, incoherent, and we also try to understand where the person look at, any specific preference. The sliders at the bottom represent the brainwave measurement, which is about we call it the frontal asymmetry. So if you find it pleasurable or not pleasurable, this is the product that we generate, that we made. You choose whatever and you generate whatever that will somehow make them look the overall thing to look good. This is 2D at this point in time, but it's more about the concept of an inside out kind of thinking. So it's like you buy your furniture first, and then we get an interior designer to come in, rather than the other way around. This project is also with these brainwave measurements and eye tracking, but we train 4 AI models. This is like 2023, actually 2022, end of 2022, and was looking at data set from a natural data set, meaning real life pictures of interior, and artificial modeled renderings on the web. So to see the unreal essentially, and use that and trained them with a correlation of the output of the brainwave spectrogram and the gaze pattern, meaning where you look at. And then you train 4 models. So given a brainwave signature, we can generate a design. Given a gaze pattern, you generate a design, or in fact, you can combine them. But the point here is that we're not trying to create a universal brainwave interior design matching thing, but it's a personalized model. So this is your own, because if you do the experiment, if you are the human subject that measures your own brainwave, then this is your thing. It may not be applicable to another person. And then eventually we presented it. It's actually an extension of a master project where we then presented at the AAI. It's called the Memory Palace, your Memory Palace. And at certain point, we would, so the metaverse is then generative. So which is a kind of a very different take from current way of thinking about metaverses and AI. So here we use the AI as a means to replace and substitute objects if they share similar. There are parts where we basically change the entire scene, but the idea here is that objects have different objects may share the same brain wave trigger, and that's the idea. If they share the same brainwave signature, then that means we can actually replace them in that metaverse. Teaching this is just because you guys are university students. Just to show like what's going on in SUTD. So we see there's a increased interest. Well, what is it from the student or not? I don't know. Generally, the university-wide. In fact, the whole society. So 2019, when I was asked to join the school, I started the creative machine learning elective. It was just an elective for architecture student. Term six are essentially like we have like 3 terms per year, so it's like end of second year kind of thing. And then 2022 is additional part where I started teaching the history theory of AI just to complement the hands-on machine learning elective. So it's a core, which is also very unusual, like history theory course, but in AI, about AI. And then 2023 and this year, we kind of exploded a bit where the elective is still there, but it's offered to non-architecture student, design AI student, which is the one in yellow. And also next year, I mean, I also run a special, so I teach in the architecture department, but also the design AI program, which is a separate program. They are applied computer science students. So next year, deep learning, creative machine learning is compulsory, is a core. So we have moved from an elective a few years ago into an elective that is cross faculty into a core compulsory for undergraduate students. So these are all undergraduate courses. And so we begin also of course, I have PhD students which will work mainly or exclusively on AI, but we see the trend. If you're keen, I also curated a recent spatially AI lecture series where I include people who are not necessarily working, implementing AI, but has something to say about AI to just broaden our conception of AI and architecture. I'm overrunning, right? So I'm gonna skip. So this is some student projects from the Artificial and Architecture Intelligence in Design Theory History course where they have small projects. So here the idea is how to think about new kinds of AI models without necessarily implementing them in full. So is so here is using looking at communal spaces. Could AI be used for like understanding neighborliness among tenants? So here is an app is to then allow you to actually, so you looking at different public housing communal spaces, we use a way proxy, right, to measure friendliness. So if you see your neighbor is always like putting lots of stuff outside, I don't know, this is a bit quite specific to the local context. So we measure the spillage, we do a visual question answering model to understand the objects, we segment them, we segment anything model, and we use that as a way to guess. So for instance, if you live in any of these high-rise buildings, if your neighbor always have like CCTV cameras, you know that he's probably not the most secure person, or is full of like plants and whatever. He might be someone who is like to come out, to talk to people and water his or her plants. But anyway, this is another project where we try to move beyond the visual. So what is a non-stable diffusion, non-mid-journey modality? So then it's maybe smell. So here the student looks at collection of data to train the model with different smells from different food courts, coffee shops, and use that as the basis to generate spatial configuration. So you see that some food are very complex. Like, I don't know, the chicken rice is not as complex as the fishball store. But this is trying to reconceptualize reconceptualize AI models. This one I'll skip. Yeah, maybe you can let me know how many more minutes do I have, or I should end now, and then I can end now. Maybe you can let me know. I can't see the.
You could try to conclude in 5-10 minutes, and then we can put some questions.
5 to 10 minutes or 5 minutes?
Yes.
Okay. Right. So this actually is an experimental project. It's with the Agency for Science and Technology and Research, also with another university, looking at brain to architecture. So you've seen some of the brain project, but you see some of 3D project, but this is almost in combination. So can we think to build? Can we think architecture to generate architecture? But before that, we need to know how to represent in low dimension. Just like you could represent the brainwave with a spectrogram. So how might we possibly represent? So one of the approaches is to look at kind of a low dimensional understanding of spaces. Here, the pixels, right? Very simple, 8 by 8. And we use that as a basis to then also generate new ones. So this is part of another thesis project, but is sort of related to the new project, the Brain and Architecture project. But here is not to constrain. So this is with, if you're familiar, this like IP adapters, where you could decide on the colors, but not decide on the composition in a very explicit way. Just like if you use ControlNet with the canny edges, you can control the composition very accurately. But here we want to loosen that control. Yes. This project we work with, this is a spatial design studio. These are non-architecture students, but they're working on architecture stuff. So we work with industry partners like Autodesk or the former engineers, and an architecture office who is interested. So we use large language models to script all the entire compliance requirements from the planning agency. And then with that, we embed it into originally the former, the Autodesk former, but we figure out that it's too restrictive. So after that, they create their own web app. So you could say, if I choose a location in Singapore, if I choose a location in Singapore, it would then immediately retrieve the setback is not really retrieve, it's actually questioning the fine-tuned large language model. Actually, I think we were using RAG back then in context. So in that sense, we can also load different generative models, so you're not restricted by GANs or diffusion models. The idea is that you can have many options. So it was a prototype. This project I won't show, but this is about reinforcement learning that we do with the Spatial Design Studio. Is trying to figure out how to organize space, not based on optimal working condition, but only optimal in the sense of the personality of each of the individual. So if you're an introvert, how best in a group of 4? Some are introverts, some are extrovert. Can we train a reinforcement learning to configure the space such that you up the teamwork? So in fact, the human subjects were for the personality tests were the students, the co-class, about 30 to 40. This project is the brain. This is a university-wide thing that I'm leading. So it's about this multimodal understanding, and we're using we're starting with Tiny Llama, which is a small version for sustainable reason, because it consumes less power, it has less parameter, but it's performative, and therefore the GPU hours is also shorter for the training. So there is this increasingly other concerns beside having a powerful model, other sustainable concerns, ethical concerns about data sets, about resource. Here, this is the kind of early concept of the design brain, where it's a simplified version. But the idea here is that you could begin to cross domain. So in AI research, there's been discussion about can we not train everything like from scratch, or even if it's fine-tuned? Can we actually use adjacent domain or discipline models from this adjacent one and use it instead? So that means you don't have to fine-tune. You only need to see the relevant overlaps of different domains. So this is from a resource perspective. And yeah, this I just let it. It's quite similar, but here we are more concerned with the sustainable attributes, not just compliance. But this is more at the concept level. This project is still very much in progress. So this is not the real app yet, but the one you saw was the real prototype app. This is a bit slow. I should hang. But anyway, you get so this is just one aspect of it, of the design. This I'll skip. I might, 5 minutes. I'm just gonna end this. So this is about trying to understand high rise. This is in the more like a neurocognition thing that we're working on right now. Is to see whether high rise could in fact have a legitimate, explicit, data-driven way of deciding on its facade based on biosensors. So for instance, in high rise, in this project, which is also an extension of the master project, is to look at how to measure the aesthetics of high rise building by first algorithmically. So the extension was the AI part, where we train a model that could predict its explicit facade, let's say figure ground, let's say, I don't know, facade transparency, so on and so forth. And then in the end, the whole point is to actually generate the facade system. Yep, this is all I have. I skipped some because we have no time. Yep, thanks.
Thank you, Professor, for your insights on the subject. It was really intriguing to see how and to what extent there is a possibility of integrating AI with architecture and the implications for the same. So thank you very much for the very informative lecture. We
Sure.
would now like to open up the platform for questions. So please go ahead, and if you prefer, you can also drop your questions in the chat box. Um,
Hi, I had a question. So, kind of a larger question on ethics and ownership when you use something that is AI generator, AI as part of the design process, and especially in a field like architecture where originality and creativity are so highly valued. How does this kind of play a factor into the client's mind or even the mind of the architect or whoever is kind of giving an input into the software to generate an AI generated out?
Sorry, I couldn't catch some parts of it. So, are you asking, is there any concerns in terms of the originality and creativity of the architect or the ethics part of the training set? I might have missed some part of it.
Yes, mostly about that.
Right. So how do we negotiate this potential issue of, let's say, architects to use these models with other data sets that they do not own and claim is theirs in front of the client, and therefore almost indirectly or discrediting their creativity or reducing their creativity or in at this creative agency. I think this is not so straightforward, because even if one were to just use black box models where you just use it as it is, Midjourney or whatsoever, there is still certain degree of decision making, but the process will be tricky which is something that is within the design world or art world as well, right? Architects don't really like to unveil the mystery of the design process or the creative process. And in the case of these black box AI models, is even more, it's impossible even if you want to unveil it, because architects don't even understand what's going on in there, right? So they would find themselves dumbstruck or not being able to explain if needed. And that's actually part of the issue, because this also almost grant the client or the excuse to say they could have done it themselves, right? Of course, then the architect would say, okay, you need the eye of the architect to kind of make some decision that makes sense and is sensitivity. But certain part of the design process do not require such sensitivity, maybe. And yeah, it's a difficult issue to address, but it is dependent on the degree of involvement of the architect with these AI models. So in the case where like the case of ZHA or MVRDV, I mean, they train their own model, right? So data set, there's no problem. Model is joint IP, no problem. So, and they will be, because in the process I have to do a documentation, right? They will be made known of the process. So that's different. They have no issue with that. Yeah. I don't know if I answered your question, but it's a question of the AI model, what goes in and how it's designed, and do you actually make changes in more fundamental ways that then you could say that is by you to some extent, even though not fully, which is happening now increasingly with the two shots training with Laura, and it is beginning to happen, which is a good thing. Yeah. Any other questions?
Yeah. So I wanted to ask about, so you said the idea premise of integrating AI with architecture was about the fundamental shift in the conception of architecture and thus generating new aesthetics. So how is doing this through a trained model different from a human doing the same through their learnings of previous architectural projects? Is the factor the difference in time between the two? Because why do we say that AI broadens the concept of architecture if AI is also functioning on the basis of a trained model or on rules programmed on intentionality?
Yes, so that's why I stated two possible takes on this, which is the artificializing or the architecturalizing part of it. So if we're just architecturalizing, the artificial is a kind of a production sense. So in a way, there is no potentially fundamental difference between without AI and with AI in that sense, because we still have the same concept of a building needs to have an entrance, it needs to have, that kind of thing, right? It needs to be of a certain scale. So you don't need that, but you can do it faster. But what I'm trying to hint on or discuss is the kind of unexpected affordances or augmentation or distortion brought about by these AI systems that have a different, if you like, style of thinking or style of simulating. And this is where there might be new aesthetic opportunities and new epistemological opportunity. It's just like, I mean, if you think about the contribution of Picasso, the Cubist movement, or the Impressionist, it's really about reinventing of the vision, right? That you are, so in that sense, of course, a human can do it, but in this case, what I'm saying is that the machine has some kind of aesthetic inclination, some kind of formal inclination. And we also have to be very careful about the use of the word AI aesthetics, because AI aesthetic can refer to the cliche ones, where the aesthetic emerged from this widespread use of a certain tool in a certain way, that in a typical way, right? So it creates seemingly a shared aesthetic, but the AI aesthetic from a more innovative approach is where you try to understand the system and you try to push it in its non-predetermined direction within the domain. So what does it mean, let's say, to have the Janus effect in architecture? Does it make sense to have no front facade? You have multi-facade, or what does it mean to have? Yeah, so it is this sort of interesting formal tendency that may broaden our conception. Yeah.
Thank you. And we do have another question in the chat. It's from Ankritya. She's asked, at what point do you stop relying on the results of AI output and rely on instinct for design? Is this parameter driven or just designer's gut?
So at every point, you have to make decision. So as I mentioned, even if you do finding, you still have to decide for few shot learning. You still have to decide which are the few data points that you're going to throw in, the images or the 3D model whatsoever. You have to decide on which AI models. If you are going very deep, you can actually decide, and you can make hyperparameters changes, not just in the sense of the sliders that you do, but also the architecture of the neural network, deciding and evaluating its output by making changes to its structure. You also make decision from the output to curate which are the ones that seems interesting, and if they are generally not interesting, then you go back and you sort of rerun the thing to check, if maybe change the data set again, maybe change the parameters again. And then after that, once you have arrived at a list of an array of interesting design, then you have to decide which one to go. Maybe in the end is that you then combine them implicitly as a designer. So that's why you actually even do a cut from, because it's almost at this point in time impossible to have a fully designed thing right out of it, right out from the model. Yes, like the bench, we generate the whole 3D model out, but we still have to do a bit of optimization to make sure it can actually stand, because the model has no concept of gravity or structural coherence. So that's when you start to use your parametric system to do the structural optimization. You begin to think about, like, for instance, the output was amassing for that bench, but the decision is to actually populate the whole bench with about 6,000, 7,000 equilateral triangles to create this tessellated effect. So that's a human decision. The model doesn't actually do the tessellation for us, although we actually did with a more kind of a top-down decision with a parametric model to remesh, to re-articulate the surface, the mesh faces distribution. So these are human input. And then when we fabricate it, what material, right? Because it's essentially a non-material thing. Do we make it in wood or something else? Well, it depends on the concept. But in our the concept is to upcycle, not just conceptually but also materially, the training or the bench, the furniture and the boat, right? So those are also decisions. How to place it on site in relation to the context, those are also decisions. So yeah, the human is always in the loop. Well, at least in how we work in our lab.
Thank you. There's another question in the chat box. As of now, intuition is one of the main aspects of architectural design. Where will intuition of the human mind come in the picture in relation between AI and architecture? Do you think logic or rationalizing decisions surpass intuition because of this? This is asked by Dhruv Kothari.
Right. So I think the assumption is that these models are always rational, but honestly, if you look at the Gen AI output, they are actually not rational. They are just, in the case of LM, it's just deceptively convincing and seemingly rational. But actually, often we do fact checks. You can ask the ChatGPT to generate whatever. The references are all wrong, right? The authors they don't exist. Or if so, there is this somehow this assumption that the machine is always rational. But actually, some of the projects that I show you were using its human, the inhuman, the non-human understanding of the world of design objects. As I said, it doesn't know what's a 3D object because it has only seen a 2D world. It doesn't know gravity because it has never lived in a physical world. So actually, it's highly irrational. So that's one way to talk about the rationality of the machine, which belongs to the older AI, where is an automated system where it's a rule-based system. It has no agency because it's just following the exact rule. So it's completely logical and rule-based, and you can check the facts. Here we can't actually, even if it's generating something that is not rational, we can't even figure out why is it generating, which is the part in the algorithm that is causing this irrational behavior. Nobody knows actually, because we don't understand the weights in a very precise sense. The notion of intuition is also sometimes over glorified. I think intuition is extremely important, but sometimes when it goes against your intuition is where the innovation also happens, because the intuition is something that you bring along with you, which is very precious, very personal, with real life experiences. But sometimes it's also the very hurdle that you need to cross that is counterintuitive but yet amazing, just like quantum mechanics, right? It's counterintuitive. Nobody understands. It's very difficult to understand. I don't understand. So it's counterintuitive. Doesn't mean it's not. It doesn't mean it's not amazing. Amazing theory. No, it's not true. It's just weird, right? Because we can't conceptualize it, right? Just like when I refer to Max Fisher, it's our inability, or you can then translate that our inability of our intuition to actually go beyond our intuition. And we try to use AI system to perhaps work with our intuition and sometimes even question our intuition. Yeah.
Thank you. We still have time for one or two more questions. So if anyone would like to ask.
Hello, can you hear me?
Yep.
So in one of your slides, I think the title is called Brain and Architecture. It kind of takes graphical outputs, and then you've also used pixelation to generate a low-res image. So my doubt here is how are you connecting the graphical output which you're getting, and what's the relation between that pixelated parts of the image and the graphs which you have generated from the brain, like the machine. So I'm just trying to connect the dots between these two.
Yes. So these two, the dots are actually not connected yet. Therefore, it seems confusing, because that project is a new project that we are starting, and the idea is to use implicit input to generate spatial construction. So the ingredients would be the trying to correlate to map brainwave patterns and gaze map patterns or whatever biosensing patterns, and with some explicit input, maybe in text or language, by fine-tuning large language models, and then use that to generate an array images that then we use a 2D kind of a neural radiance field reconstruction or 3D Gaussian splatting reconstruction to then generate a space, and then from there we begin to evaluate their navigational logic. So when I show that low-res representation of a scene, is only to clarify that there is a need to abstract information to the point that is low enough for diversity or generation or for generativity, but high enough to be encoded. So in that sense, is a bit, it seems a bit a bit confusing, because that from that set of slides onwards with the low, the 8x8 pixels, those are experiment of trying to understand how best to represent memory. So we may remember a place with the smell or the color palette. So in AI research, there have been work done to reconstruct brain to image by abstracting the image as a set of pixels, because it captures the not so much the composition but the field of the place. So I'm just showing that as one possible way of representing memory or vision.
Okay.
Right. I hope that clarified. Yeah.
Yeah, it does. It does.
Yeah.
And one more doubt which I have regarding the chair, the projects which we have mentioned. I think it's the chair one, the first one, where the second chair which you have exhibited in various museums. So based on one of the videos, you've tried to generate that particular chair, which kind of provides you a lot of views around the space. In one of your videos, it kind of generates it through different views, let us say different elevations of the palette of chairs which you have picked from everywhere. So based on the definition which you have provided in the starting, the theory part of the lecture, where you are creating or you're trying to create the processes which we use to create the architecture, not using the AI tools to produce architecture, but using AI to derive systems. So is this a system which you have derived to generate this chair module through a pattern of views or through collection of palettes? So am I right? Am I in the right direction saying that you have created that system of extracting palette and of chairs and like creating that module through different views and generating that module? So
Yes. So yeah.
so yeah,
It's
so the ultimate
mhm.
output of the chair was to kind of have different kind of seatings, and it's like an artifact, like you mentioned in your definition. So am I on the right track in terms of putting it in the right way, the whole process and then the theory part of it together?
Yeah. This more or less. You're right, more or less. Because it can, these sort of hypercubist chair, the very fact that they have this because of their very process, right? That they made up a 3D object from a 2D world where some views are missing, and through that is almost like a glitch and a kind of glitch in a digital imaging sense. Yeah, so it's you're quite right. Those are physical manifestation of the underlying process, but through that it produces a different way of thinking about the function of a chair or a furniture, that it doesn't have to be necessarily single seated. That doesn't necessarily have access around it. Yeah, so it is one way to express this process.
I think it redefines the idea of a chair, like the process which you're kind of getting into, the system which you derive. The byproduct is not just a chair, but it's going to change the definition of it, like providing multiple. It's not just a single direction. So
Yep, exactly. And hopefully we can actually push that in the architecture sense, where usually furniture is faster to to produce and to demonstrate for now.
That's it. Thank you very much, and amazing.
Thanks.
Thank you. So if there are no further questions, then we will be wrapping up the event for today. We sincerely thank you once again for taking the time to engage in a discourse with us regarding this topic. And to everyone who joined us for this Preforum event today, thank you. We look forward to seeing everyone again on the next event on 29th July, Thinking Being Modern, which will be conducted in person on campus. So thank you to everyone once again.
Thanks everyone.
Yeah.
Okay. Thanks. So I make a move now. Bye.
Bye-bye.
Bye.
Well.